If you want to learn 20 Blender tricks while creating epic scenes like these that can be easily rendered in Eevee or cycles, sit your chicks down and let's get into it. It's amazing how much you can create with just simple shapes like cubes. I'm going to make a small building starting with a cube, stretching it to form columns, walls, and a slab. Most of the details will come in during the texturing stage, which is quick and easy. If you want speed and quick delivery, skip PBR textures and complicated shaders. Just use single image textures to get the job done. Unless you're planning to move the camera really close, you can ignore bump and normal maps. Most of the time, they don't even look great unless you find a really good one, and from a distance, they won't show at all. For UVs, a quick box projection map works best for this kind of texturing. If it doesn't suit the image you're using, you can always create another UV map. I'll also add an amazing 3D scanned ground that has incredible detail that's nearly impossible to model. And guess what? This ground doesn't use roughness or normal maps either, yet it still looks great. The ground is packed with small rocks, and scaling it up would make them look too large. So instead, duplicate the ground object to maintain the scale and cover more area, rotating each duplicate slightly to hide any hard edges. When I mentioned single image texturing, I didn't mean using just one image for everything. I meant focusing primarily on the diffuse texture. The concrete we have looks too plain with only one texture, so let's add another layer of detail, like water damage. Search for water damage textures on Google, find one that works for your scene, and let's add it in. We can blend this texture with the concrete using a mix node, setting the mode to overlay. For even more detail, let's add another image. This time, search for a rain damage texture on Google and choose a good one. Mix it with the other two textures for a richer look. To keep the water streaks directional without affecting the other textures, we'll create a new UV map. Go to the UV Maps panel and create a new UV map. In the material, add a UV map node and select the new map we just created. This lets us adjust the UVs for the water streaks independently, adding realistic detail without altering the original textures. Make sure to blend the water damage and rain textures with the others, using a multiply or overlay blending mode for a more realistic result. Once everything is blended, connect the final output to the base color in your material. Here's a handy trick for working with HDRI lighting. Go to the shader editor, switch to the world settings, and select the environment texture node. Use Ctrl-T to automatically add texture coordinate and mapping nodes. Change the coordinate type to object, then add an empty to your scene. Use this empty as the target object in the texture coordinate node. Now you can easily rotate the HDRI lighting by simply rotating the empty, giving you precise control over the light direction in your scene. Blender 4.3 introduces a new volume shader that's perfect for creating realistic dust effects, so let's take full advantage of it. Start by adding a cube to your scene and scaling it to cover the area where you want the dust. Assign it a new material, and replace the principled shader with a volume scatter node. Choose a dusty color for the volume and adjust the density to get the desired effect. Add a noise texture to control the density of the volume. This will create the effect of a dusty environment. Add a color ramp node to control the contrast of the noise. To animate the dust, connect the noise texture to a mapping node and keyframe the Y value or any coordinate of the mapping node. Alternatively, use a frame driver, e.g. frame/50, for continuous animation. This setup will give your scene a lively, atmospheric touch with minimal effort. Now let's work on the camera animation. For smooth camera movement, follow these steps. 1. Parent your camera to an empty. 2. Add a track 2 constraint to the empty, the one the camera is parented to, and set it to look at another empty. 3. Clear the rotation of the camera so it faces the direction of the empty with the track 2 constraint. The beauty of this setup is that your camera remains free to move and rotate because it doesn't have the constraint directly applied to it. However, it will always look at a specific target due to its parent's constraint. You can animate both the look at empty and the parent empty to achieve smooth and dynamic camera animations. When the camera gets up close, especially near the ground, the resolution and detail of the ground might look lacking or blurry. To maintain high quality in close-ups, duplicate the ground mesh, scale it down, and position it close to the camera. This ensures the camera sees finer details up close. Scaling down the mesh effectively compresses more detail into a smaller area. Since the ground is made up of small rocks, this technique makes them appear even smaller, which works well visually. However, scaling up wouldn't work the same way. When you scale an object or texture up, it takes up more screen space, spreading the detail over a larger area, which can make it look stretched and low quality because of the texture or mesh's limited resolution. Additionally, consider the actual scale of the rocks on the mesh. Large rocks look realistic only up to a certain point. Beyond that, they can appear unnatural. On the other hand, smaller rocks and pebbles can scale down infinitely without breaking realism. Showing smaller rocks adds more detail and enhances the overall look. Just be mindful of where these meshes intersect. Ensure they blend seamlessly with the surrounding environment to maintain a natural appearance. To make all the assets blend seamlessly, it's essential to adjust their hues, especially for scanned 3D objects like the ground. These are often scanned under different lighting conditions and at different times of day, so their colors won't always match. One way to fix this is to add a noise texture and mix it with the ground material to introduce slight color variations. This adds a natural feel to the ground, mimicking the subtle inconsistencies you'd find in real environments. Similarly, you can tweak the colors of other assets, like adding a bit of color to the concrete house so it harmonizes better with the environment. By matching the hues and adding subtle variations, the scene will feel more cohesive and realistic. Finally, let's simulate some wind by adding papers being blown around. Start by creating a subdivided plane, then duplicate it a few times in different areas. Assign a cloth simulation to the planes to make them behave like paper. Add a strong wind force field to blow the papers away, and set the house as a collider object to interact with the flying papers. However, since we're using a high-poly 3D scanned mesh for the ground, making it a collider will significantly slow down the simulation. To optimize this, 1. Create a large plane covering the scene. 2. Add a shrink wrap modifier to this plane and set the mode to project. 3. Select the ground objects as the target for the shrink wrap modifier. Each modifier can only target 2 objects, so add additional modifiers to handle any extra ground objects, keeping the same settings. This will project the plane onto the ground, morphing it to match the shape of the terrain. Now use this projected plane as the collider object for the simulation. This setup ensures that the papers collide accurately with the ground and the house while keeping the simulation performance smooth. And that's it, my friends. That's how you can create epic scenes in just a few minutes. Before I let you go, be sure to leave a comment and let me know if you spotted any tricks you hadn't seen before. I always love wowing you with new techniques, but it's getting tougher as you all become experts yourselves. Don't worry though, I'll keep trying. Also, check out this amazing Geometry Nodes course by Top Channel 1-on-1. It started as an introduction to geometry nodes in Blender, but has evolved into a full-blown motion graphics course as new chapters and lectures are added. Thanks for watching, and I'll see you next time.